usual, we are going to make sure that this is on record to allow those who could not make it to join us, and they can be able to listen to this class at a later stage. Or even some of us, some of you who are here, you are also able even to revisit and download it and listen to the video again, so that we can get a very, very good and in-depth understanding of this particular module. So these are my my contact details on WhatsApp. So if you have any concerns concerning this module, you can also send a WhatsApp message, and then we can communicate on this number, right? So let's get straight into today's details. Yes, it is on record. Yeah, I see others are asking if this is being recorded. Yes, it's on record. So this is it, guys. This is ECS 3706, which is econometrics. And before we go into our slides, I just want to define what econometrics is, just from an abstract view. So econometrics, we can separate this word econometrics into two separate words. We can say econo, and then we end here, and then we put another word, metrics. So if you look at this closely, you can see that there are two words that are joined. We have econo, which is short for economy, then metrics. Metrics is about measurement, okay? It's about quantification. So what are we doing generally when we are studying econometrics? Basically, econometrics is about the quantification of the performance of the economy, if we might want to put it in a layman's language. But we are going to use our economic terms or econometric terms to define econometrics, as you shall see in the following slides, right? So what is econometrics? So when we are learning any module, be it for the first time or we are revisiting, the introduction, we need to understand what exactly that particular module deals with. So in this case, econometrics is the application of statistical methods to economic data in order to give empirical content to economic relationships. So in this case, you have seen that I've tried to underline some key aspects or some key notions that we need to be very, very, very careful about when you are defining economics or econometrics, or when you need to understand more about econometrics. So number one, we have statistical methods. So we are applying statistical methods to economic data in order to give empirical content to economic relationships. So if I want to try and visualize econometrics, we can see that there are three main inputs that would formulate or that would form econometrics. Number one, we have statistics. Number two, we have data, and should be economic data. Number three, we have economics. So when we are studying econometrics, we are having an amalgamation or a combination of these three aspects, grouping them and studying them all at once. Let me show you something that can be interesting. At this level, I believe most of us have done mathematics at level 1, which is mathematics for economists, in which you'll be studying pure maths that would help you to apply it in other modules that are going to follow. Right, so in this case, I can illustrate econometrics in this manner. Okay, that's what I can illustrate econometrics, sorry, in this format, in which I would say this is statistics. So I'll shorten it stats. And this is economics. And I will put it here as another subset. All right, then we'll put it data or data. Yeah, right. So it means that when we are studying econometrics, we are studying three different disciplines that are being brought together to form what we now term econometrics. So where do we find econometrics? Econometrics would be here. If you have done sets in your mathematical courses earlier on, you should understand what I'm saying. So it's an intersection of economics, statistics, and economic data. So which means here we'll be having the universal set will be here. And then we have all those three disciplines all together. And then so here is where we would find econometrics as a discipline. So it is not a standalone discipline, but it is found as a subset of other disciplines. So I think by this illustration, you can be able to tell what you are expecting in this module. Right, let's go back to where we were and finish off the introduction. Remember, today's class is just an introduction, but we are going to have such classes probably same time so that we can be able to complete this module on time and people can have time to revise and revisit some concepts and be able to apply them in various exam conditions or circumstances. So, right, we have shown that econometrics is an application of statistical methods to economic data in order to give empirical content to economic relationships. So at this level, guys, I wouldn't want to lie to you. This assumption is that most of us, if not all, are very well vexed with the low-level economic theory, statistical principles, as well as data, right? So that we are not going to go deep into it because we assume that at this level, you have at least once came across the application of all those disciplines. So in other words, it turns what is it in this case? We are talking about econometrics. So we are saying, in other words, econometrics turns theoretical economic models into useful tools for economic policy making. As you shall see, when we are discussing the uses of econometrics, you would find out that there is the Reserve Bank of South Africa, SARB, might announce that they are expecting inflation for the following year or for this year to be averaging around 3% to 5%, for instance. And then you would wonder, how did they come up with such forecasting? And that's the purpose of econometrics. You'd find that they will collect data, then they will use historical data to predict future behavior of the economy. So you shall see when we discuss on the uses of econometrics, right? So when we are studying econometrics, we are simply taking a theory and quantifying it. What are we saying when we are looking at, we take a theory and then we quantify it? Remember, most of us here, I wouldn't want to generalize to say all, but most of us, we understand the theory of demand, the theory of supply, and many other theories, or theory of consumption, etc. We know that basically theory predicts that quantity demanded declines if the price of that particular good increases. So based on that, we understand that there is a negative relationship between the price of a commodity and the quantity demanded of that particular good. So in this case, we understand that the theory tells us that there is a negative relationship between these two variables. However, we don't know the magnitude or the strength or direction of that. We know the direction, of course, because it's negative, but maybe the strength of that relationship, we don't know. So that's what we can use. That's how we can use econometrics to quantify an existing theory. All right, so econometrics allows economists to sift through mountains of data to extract simple relationships. So there will be multiple mountains of data that will be existing. And then the purpose of us as economists or econometricians is to extract simple relationship that will be existing in mountains, in those mountains of data. Don't worry, you shall see how this is applicable. So in order to explain what econometrics is, one can look at its goal, method, and its uses. So for you to be able to understand econometrics, one way of doing that is to look at its goal, look at its methods, look at its uses. So that's another way of understanding econometrics as a discipline. Right, so now, because we've said for you to understand econometrics, there is need for you to look at the goals, methods, and uses. So now let's look at these goals, the method, and the uses of econometrics. The goal of econometrics is the estimation of economic relationships. So if you're an economist or an econometrician, if someone asks you the purpose or the objective, I mean, of econometrics, it is the estimation of economic relationships. But what do we mean by economic relationships? By now, as I've mentioned earlier on, we assume that you have dealt with multiple economic relationships. Number one, I'll give you an example. We all have came across the Phillips curve, and there is a relationship that is presented by the Phillips curve, that is the negative relationship between unemployment and what? Inflation. So this is theoretical. But when we are doing econometrics now, we are quantifying the theory. Okay? Number one, quantity, maybe let's say the theory of demand theory. The theory of demand, basically, it would tell you that price is equals to A plus B Q, something like this. This is a theoretical relationship because we understand that the price of a good is explained by the quantity demanded of that particular good. This is the inverse demand function of a particular good. Let's look at the supply theory as well. It's almost similar to the demand theory, right? Let's look at another different theory, which can be the consumption theory. Okay, I'm taking you back to your micro and macroeconomics. So here, the consumption theory will tell you that total consumption in an economy is explained by autonomous consumption plus the marginal propensity to consume by income, like this. And we remember that this A is the autonomous consumption, that is consumption that does not depend on income, which means even if when income is equals to zero here, an individual still consumes something. And that something could be through borrowing, etc., or de-saving. When you withdraw from your savings, even though you don't have income, but you have accumulated savings before, so you are de-saving. Of course, at this level, we are not going deep into economic theory because it's an assumption that you know that. So we are saying consumption depends on income. So if income goes up, consumption also rises. If income goes down, consumption also falls. So we assume that this B is going to be positive to explain the idea that there's a positive relationship between income and consumption, right? So in general, what we are saying is that in economic theory, we are just given these equations, which are more theoretical, but we don't know the actual values of these letters or of these parameters. We call them parameters in econometrics, or yes, we call them parameters or coefficients, right? Because they are unknown. So when we are doing econometrics, we want to estimate the actual value of these parameters so that we can be able to tell that if quantity demanded increases by this much, how is our price going to respond in that case? Or if price increases by this much, how is quantity demanded going to respond? For instance, if you look at this equation here, if we estimate this beta and we know, for instance, it's 2, then we can be able to predict by how much is our consumption going to change if there is a unit increase in income. But at the moment, don't worry about the interpretation of these equations, but I'm just showing you how or the nature of some of the equations and theories that we can meet in this regard. Right, so let's go back to where we were. Right, so we're saying the goal of econometrics is the estimation of economic relationships. And in this case, our digression, it came because I wanted to explain to you what are economic relationships. And the goal of econometrics is to estimate those economic relationships. And those economic relationships that I was mentioning are those economic theories, which tells you that there is a positive relationship between quantity supplied and its price. Or maybe there is a negative relationship between unemployment and inflation, according to the Phillips curve. So its method, remember this topic deals with the goal, method, and uses. The method that is normally used in econometrics is regression analysis using actual data. So in this module, you're going to understand what is regression analysis, right? We are going to define this term and put it in a more simplified manner so that even when you are asked unaware, you can be able to illustrate regression analysis and see how it is applied in econometrics. So the main method that is used in econometrics is regression analysis. And we make use of actual data that we collect. We can get it from the World Bank. You can get it from SARB. You can get it from any other reliable source of data. Right, so the use now of econometrics, there are three main uses of econometrics. Number one, there is structural analysis. Number two, there is forecasting, which is prediction. Number three, there is policy evaluation. By policy evaluation, okay, don't worry, as we are going to explain each of these uses just in the following slides. But these are the three econometrics, the uses of econometrics as they are. So you must know them as an econometrician because it can help you even when you are reading this module, you understand why are you doing it? How are you going to use the principles that you are learning? So those are the three aspects that you can use econometrics for. So the econometric approach is represented schematically in the figure that follows. So if you look at this figure, it shows us the econometric approach and its uses. So in the method or inputs, we have economic theory, right? Which is the economic relationships. And we can also make use of statistical theory. Okay, we can make use of statistical theory. So these, what we see here in this first block here, these are the inputs or the methods. So you start with economic theory, and then you express the model in mathematical terms. Like, you know, from theory that quantity demanded is negatively related with the price of a good. So you can present that model statistically, mathematically, sorry, in which you show that price is equals to A plus BP, BQ, okay? Price is equals to, let me go take you back a bit. All right. So here, from theory, we can present the theory in mathematical form. So this is what we are doing here when we are referring to this aspect where we are modeling, when we present a model in mathematical terms. Then from the mathematical equation or the mathematical model, that's when we can present an econometric model, right? Right. Another input as well is data, as you have seen in our previous slide when we were saying when we're discussing the aspect of econometrics being studied within three different departments or three different disciplines. We have economic theory, we have data, we have statistical theory or statistics. So all these three inputs, three categories of inputs, they feed into our main goal, which is to estimate the econometric model. Using these inputs here, we are able to achieve the goal of econometrics, which is to estimate the econometric model. What are the uses now of econometrics? The uses of econometrics are structural analysis, policy evaluation, and forecasting. So maybe forecasting, of course, we've briefly touched on it because that's when you'll be predicting the future performance of an economy or the future behavior of customers or something like that. Policy evaluation, we are going to look at that. Structural analysis, we're going also to look at that. This is just a repetition of what we have discussed already, but econometrics makes use of the following inputs or disciplines, which is economic theory, economic data, and statistics. So in this case, don't be surprised if you see some of those economic models that we're doing in microeconomics, or maybe in international trade, if you have came up across such. But it doesn't stop you from doing this module, even if you have forgotten some of those principles, because you can always revisit and read and understand some of these concepts. So like I've said before, the strong assumption is that everybody understands basic economic theory, all right? and also you have done and understood statistics. But in case you have forgotten, still there is room for you to revisit and also come back and proceed with this module. It won't stop you from passing this module. So these are the three uses, the three inputs that we make use of in econometrics. Right, let me just indicate this. If you're having a question that you want me to explain and present it in a more clear way, you can just raise your hand and then we will be able to address your question now before you forget your question. Right, so let's move on. We start with economic theory because this is the foundation of econometrics. Without economic theory, we don't have econometrics. We need to understand what does economic theory say about something. Then we build from there, right? So at this stage, we assume that we have encountered various economic theories. By various, I mean like as many economic theories as possible, right? There are a lot of them. And some of them you should be able to present them in a mathematical manner or in a mathematical form. So some of them, for example, the demand curve, we know that P is equals to A plus B QD. That is borrowed from microeconomics, where P is our price, QD is quantity demanded. The consumption function is where we say consumption function is equals to C, which is equals to C plus CY, where C is private consumption, Y is our income, and C, small letter c, is the marginal propensity to consume. Right. Let's move on with what we are expected to know as far as economic theory is concerned. So in previous economic modules, which includes macroeconomics, microeconomics, is the basic ones are those two, macro and micro. The above theories were treated in a theoretical fashion. We were just told that price is cost to this, consumption is cost to that, and maybe savings is cost to this, but we didn't even know how can we quantify that theoretical equation. How can we come up with some numbers that can show us what happens to this variable if this variable increases by this much. So to be of real use, however, one requires accurate estimates thereof. By accurate estimates, we are talking of accurate estimates of this A here, if it's for the demand function, and for this B here, for this very same demand function. The same also applies if the consumption function. We would want to estimate these coefficients, C and this C, right? So that we are able to practically use these equations, either to forecast or to analyze structurally, or maybe to evaluate policies that have been set by the government. So the goal of econometrics is to estimate these parameters, to come up with some estimates of this demand function. So econometrics provides methods to estimate these coefficients using actual data. So if for example, if it is for the demand for bread, we want to see if really the price of bread and the quantity demanded of bread are negatively related. What do? We go and collect the prices of the price of bread over maybe 10 years or 20 years or 50 years. Okay, we take those prices and then we run a regression against the quantity demanded for the respective years, right? And then by doing so, you are able to come up with estimates, accurate estimates of this A and this B. And therefore, this equation now will become of use for us, either for prediction, policy evaluation, or structural analysis. So that's why we are saying econometrics provides methods that are used to estimate the coefficients that we are talking about, which is this A and this B, or this C and this small letter c. Right. So we are still on economic theory. So it is important to, in econometrics, it is very important in econometrics to Okay, sorry. Economic theory is important in econometrics as it provides knowledge about the nature of economic relationships, right? So economic theory provides us with the nature of economic relationship. So it allows us to know how price is related to quantity demanded of a good. How is consumption related with income? If you increase income for an individual, how is consumption going to respond? So that's knowledge about the nature of economic relationships, right? So it also helps us to choose the variables as well as the functional form to be used in regression analysis. Remember, if you want to estimate a demand function, for example, let's say you want to estimate a demand function like QD, as an example, is equals to A plus B. So economic theory helps you to know what kind of variables can I include in my model. For example, you think of price of that particular good plus C, another variable that affects quantity demanded of a good. It is the price of other goods, which we can call in this case PX, just to simplify things. What else can cause a change in the demand for a particular good? Obviously, income would come into play, and you can put a Y here. And then, so when you're formulating this equation, you are taking this from economic theory. Your economic knowledge or your economic thinking cap would be helping you to come up with the various variables that you can put in this particular regression equation, right? So we are saying quantity demanded in this case depends on the price of that particular good, the price of other goods, the income that an individual has, etc. So we have a lot of variables that can have an impact on the price, on the quantity demanded of a good. So what we are saying here in this case is the idea that economic theory helps us to know which variables and what kind of a functional form can I use if, for example, I want to estimate demand for bread. Okay, so it is you borrow that from your economic knowledge, economic thinking, economic analysis. So in this module, we assume that you are very, very familiar with intermediate micro and macroeconomics models and their specification. The process of converting economic theory into a mathematical form is called the specification of a model, right? As an example, right, just to a housekeeping, if you're joining us, please, we beg you to mute your microphone so that we don't hear your background sound or your background feedback. Okay, so please, just when you're joining, try by all means to mute your mic unless or otherwise you want to say something or to ask a question, right? Thank you very much for understanding. So we are saying we have our economic theory, but we transform economic theory into a mathematical equation, right? A very good example is what I've just shown you here, right? It is from economic theory that we understand the aspect that quantity demanded of a good depends on the on price of a good. It depends on the price of other goods. It depends on the income. It also depends on tastes and preferences. You remember those determinants of demand that you learned in your 1501, 1601, or yeah, those principles of microeconomics, where you were asked to list the determinants of demand for a product. So demand for a product depends on income. It depends on the price of that good. It depends on the price of other goods. It depends on taste and preference. It depends on probably population, etc., going like that. So economic theory helps you to understand what variables to include in a particular model. Okay, so we are discussing the uses of economic theory in econometrics. How can we use economic theory in econometrics? So it helps us in formulating or specifying a model. So specification of a model, based on this definition here, we are converting economic theory into a mathematical form. So the specification of an equation involves the selection of dependent variable, which is the y variable, the variables that cause the effect, which is the x variable, as well as the functional form. So when I'm talking about specification, there are three things that I can say you should know when we are talking about model specification. What really does that entail? Number one, it is about the selection of the dependent variable, selection of the dependent variable. Number two, selection of the independent variables. Number three, selection of the correct functional form. So these three, they entail specification. Number one, we want to understand what is our dependent variable. In this case, if it's a demand function, we know that it is quantity demanded. But quantity demanded depends on some other variables. And what are those variables? Those variables are what we refer to here as independent variables. Number three, the selection of the correct functional form. By functional form, we are saying, are we going to use a linear function? Are we going to use an inverse function? Are we going to use a double log function or a semi-log function? Don't worry about functional form, because there is a whole chapter that deals with functional forms. And also there is an entire chapter that deals with specification as a whole. So don't worry, we're going to look at this in detail. Just to add to that before we move on, for example, you can find a model like y is equals to a plus b x1 plus c x2 plus d x3. For example, I'm just giving you an example, and then you find it with an E like this. This will be an econometric model. So in this case, this would be our dependent variable, because it depends on whatever happens on the right hand side. These are called independent variables. Why independent? Because they are not influenced with factors that are within this model. Okay, so they are independent. This one is dependent because it depends on x1, x2, x3. All right, so that's why we call it a dependent variable. Independent because they are exogenous, or they are affected or influenced by factors that are outside this model. Okay, so if you want to put this in a clear and more dignified manner, you can say this is our dependent variable. If this is our dependent variable, then what are these? These are our independent variables, because they are not affected or influenced by factors within this model. Okay. Number three, then if we've discussed about this as our dependent variable, these as our independent variables, what about these? And maybe perhaps the E that is also indicated there. So let me show you that these A, B, C, perhaps, and D, all these we refer to them as coefficients. Or parameters. Parameters that are to be estimated, or coefficients that are to be estimated. So when you are doing econometrics, we want to estimate these coefficients A, B, C, and D. But we are not yet done in discussing our model. There is still that E that we can see here. This E is what we refer to as the error term. And what is that error term? The error term captures all the variations or the changes in the dependent variable that are not captured by the changes in your independent variables. Because remember, when you are estimating your model, for example, if you want to estimate a weight equation, you want to determine the weight, how can we explain weight of individuals? Then you take a sample of 100 people and then you say, okay, theoretically, what explains weight gain or weight loss in individuals? Number one, you might think of diet. Number two, you might think of exercises. Number three, you might think of height of a person. Theoretically, we might think that the taller a person is, the more weight they are likely to have. So we can say diet, also exercises as well as height, etc. But you can't exhaust all the factors that can affect weight. Therefore, you can combine all the minor effects that affect weight, and then you can sum them up as the error term. So what is the duty of the error term? I'll give you an assignment to go and read about the error term, and please make sure you understand the functions of the error term. What is it used for, or what does it constitute? What exactly do you find within an error term? So it's a very important theoretical question that you can find even in the exam. So you need to understand the error term. Although we are going to look at it in a more deeper manner, but at the moment, please read on the error term and make sure you understand the error term itself. What does it constitute? Right, so now we have discussed the main components of an equation, if it's an econometric equation. Right, we have dependent variable, independent variables, the coefficients, and the error term. However, if you look at these coefficients, you can see that there are only three coefficients that have got a variable next to them, but there is one that does not have a variable next to it. This coefficient has got a special name, which is known as the constant term. Right? So I'm saying generally all these parameters, generally you categorize them as coefficients or parameters, but specifically we have constant term, a constant term, and the other ones, B, C, D, we call them slope coefficients. So you must be able to know the difference. So in this case, we have learned that we have the dependent variable, we have the independent variables, we have the coefficients or parameters, but within those parameters, we categorize them as the constant term, and the other ones are called slope coefficients. And then we have our error term as the last term in our regression equation. And please read on the error term and understand what constitutes the error term and why do we add a slope, sorry, why do we add the error term to a regression equation? Right. Right, it's a digression, of course, but it is very important because it helps you to give a helicopter view or a pictorial view of where we are going and where we are coming from. Now we are looking at economic data. Right, remember, to take you back a bit, just to remind you what we are doing here. We said there are three inputs into econometrics, which is economic data, economic theory, and statistics. So economic data, we say in econometrics, we use either time series data where the same variable is measured over time. So what is a time series? Time series is data that has been collected over time for a particular variable. If it's GDP or real GDP, we are saying we are collecting data for the period from 1960 to 1996 for South Africa. Therefore, real GDP in this case would be a time series. However, data can also be time series or cross-sectional. We have looked at time series. Now we are looking at cross-sectional. So cross-sectional data is data that has been collected at a particular point in time. Okay, so we are not looking at over time, but it's at a particular point in time. For instance, we are looking at the consumption level of people who are residing in Pretoria for that particular month, or for that particular day, or for that particular week. So we are saying it's at a point in time, but not over time. Right. So we have cross-sectional data, we have time series data. So we have cross-sectional data and time series. Then the other group of data is also called panel data. So we are now combining, or we are now having an amalgamation of cross-sectional and time series. So we are collecting data for various individual samples over time. Right. So you shall see, if you continue reading, the distinction between time series, cross-sectional, and panel data. So data are often adjusted in order to enhance their use. For example, you can use real GDP, you can use real consumption, you can use so there are various ways of adjusting data. In other cases, if you've done economic indicators as a module, you understand that we have real values of data, and then we have nominal data. So if you want, in most cases, it is good to use real variables because they provide an accurate estimation if you are using econometrics, right, instead of using nominal. So that being said, let's look at statistics as another discipline or another component that feed into econometrics. So econometrics makes extensive use of statistical techniques. So examples are the techniques of regression analysis and hypothesis testing. We have done this in statistics 1502. 1501 was descriptive statistics, 1502 inferential statistics. So now we are testing hypotheses. So we are going to borrow some of those concepts from statistics. Regression analysis, for some, it can be new, but for some, they've done regression analysis before. So we are applying those techniques. We are not going to prove formulas for various statistical aspects. We are just going to apply them and interpret the results. So don't worry about proving the validity of some statistical formulas. So econometricians must be familiar with statistical concepts such as sampling distribution, normal distribution, the t-test, the expected value of a sample estimate, and standard errors, etc. Okay, so we shall see how these aspects are applied in practical sense as we go with these classes at a later stage. So the focus of this module is on teaching students how to interpret the use and use these techniques that we have discussed, not to derive them. So you won't be asked to derive the formula for beta 1, derive the formula for beta 2, derive the formula for the t-test or whatever. We are just going to focus on the interpretation and application of the techniques. So don't worry, you are not going to be asked to prove a formula, or you are not going to be asked to derive the formula for any statistical technique, but it's only applications. But however, it requires you to have a basic foundation and understanding of statistics. Right, as I have promised you that we are going to look at the uses of econometrics in detail. Number one, we said econometrics is used for structural analysis. Structural analysis entails the quantification of economic relationships. You remember, this was the goal of econometrics, where we want to quantify an econometric relationship. Let's go back and see how this can be applicable. So when you are quantifying, remember, this can be a theoretical model. Let's say all the way up here, can be a theoretical model. So now we add the error term, it's an econometric model. But then if we are saying we are using econometrics for structural analysis, that's when we are estimating these coefficients here. So that's structural analysis. Okay, so that's the use number one of econometrics: structural analysis, quantification of economic relationship, be it a demand function, supply function, Engel curves, whatever economic theory that you can think of, consumption function, savings function, investment function, GDP, you have your aggregate expenditure model. You can also estimate all those models that we were doing in Economics 201 and 202. 2602. Right. So policy evaluation, economic models can be used by government to compare the effects of policy measures. By policy evaluation, we are saying, for instance, the SARB has decided to increase interest rates from wherever they are right now to about 20% or 15% or whatever level. We want to evaluate how such a government policy is going to affect individuals. So we can evaluate the effectiveness of various policy instruments, whether they're going to be effective, and if they're going to be effective, by what magnitude are they going to affect the general public. So we can use econometrics for policy evaluation. For instance, there was the announcement of the minimum wage recently, in recent years. So as an economist or econometrician, you might want to determine how much is that going to affect the welfare of those that are going to receive the minimum wage. Is it going to have any significant effect on the welfare of individuals, or there's no effect at all? So if you are having various policy instruments that are at the disposal of the government officials, using econometrics, it can allow you to select the best instrument that is going to provide adequate or efficient results. So the model is solved to provide a quantitative outcome for each policy option. So if you choose a policy option to increase taxes, you're going to see the results. If you choose an option to reduce government expenditure, you also have results or outcomes for each policy alternative. So we are saying policy evaluation can be another use of econometrics. The last one is forecasting, which is direct and nothing much we can explain on that, because forecasting entails a forward simulation of an econometric model. That's when you'd find out that economists would be forecasting to say, we expect the rand to fall or to lose value or to depreciate by 20% in the month of April, or in the month of June, or in the month of December, or something like that, because they use econometric models to forecast the future. So forecasting, of course, you can't be accurate, but you have to be as close as possible for us to say your forecasting is accurate or your forecasting is efficient, something like that. So these are the three uses of econometrics, and you must know them. What is regression analysis? Right? So remember, we talked about it as a method or as a technique that is used in econometrics. So regression analysis is simply a technique that is used to estimate the coefficients of the equation from the data. So a typical regression equation with more x's is as follows. yi is equals to beta 0 plus beta 1, x1i plus beta 2, x2i plus beta 3, x3i plus ... plus ei. All right. So let me just explain this to you so that you understand where we are going, where we are coming from as usual. Right. We have in econometrics a multiple regression equation. But before we look at the multiple regression equation, there is one that is very simple. It's called simple regression equation. Right. So the simple regression equation is an equation that has got a single explanatory variable. That's why it's called simple, because it only has one explanatory variable that explains one explanatory variable that explains the dependent variable. Remember, by explanatory is the same as explanatory variable or independent. This is one and the same thing, explanatory variable or independent variables. Then a multiple regression equation is an equation that has got so many, at least two, at least one, okay? Explanatory. So what are we saying? We are saying if you see any equation like y is equals to a plus b x, this is a univariate regression equation or a simple regression equation because it only has one independent variable. But you can find another regression equation that has got more than one explanatory variables, like for example this one, which is a typical regression equation, which has got more than more x's as follows, as you can see. All right, so from the above equation you should be able to understand the dependent variable, the independent variable, and the error term. Okay, here there's a repetition, but here we were supposed to put the coefficients. So by looking at this equation, you should be able to pick this one, the independent variable. This is the constant term. These are slope coefficients. These are the independent variables, and this is the error term. Right. Another important aspect that we want to discuss today, it's not going to be a long session because we are almost coming to the end of today's session. What is an estimated regression equation? We need to have a distinction between the estimated and the true regression equation. The estimated regression equation is a quantified version of the theoretical regression equation. Right, because we understand that we have an economic theory, right? And then we attempt to quantify it, but we can't get the true regression equation. We'll come up with an estimated regression equation. So we are saying the model that we estimate using the sample data that we have is what we call an estimated regression equation. However, the true or population coefficient in the relationship represents the true relationship between x, the axis, and the y, where the ES take care of the deviations from the deviations in y that are not explained by the axis. Remember, when we were talking about this error term, we said we can't exhaust all the independent variables that can explain y. Therefore, we just end up saying plus dot 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 plus EI to capture all the variations or changes in y that are not explained by the included x variables. That's why we are saying the error term captures for the deviations or the changes or the variations in y which are not explained by the axis. So notation that you need to be careful about when you are distinction between the estimated and the true regression equation is that the true population parameter, which is beta, right? And the estimated or sample parameter, which is beta hat. So what we obtain from the sample data is beta hat, which is an estimate of the true population parameter. Right, so the two concepts that run parallel to that of beta and beta hat are as follows. We have the stochastic error term, which is given by EI, as you can see in this equation. And then we also have the residual, which is given by a small letter EI, which occurs in the estimated regression equation. So when we run our regression equation, we come up with some estimates of this actual beta and an estimate of this actual beta zero. Therefore, our equation would say y hat is equals to beta zero hat plus beta hat 1 x plus EI. So this EI now is what we refer to as the residual term or the residual error term. These two aspects, especially the residual error term, we are going to look at it in detail when you are looking at the decomposition of variation. Don't worry, it's a chapter that is quite important in regression analysis, and we're going to do it in detail in the following lectures. Let's look at a very, very simplified version or a simple example of regression analysis, right? Right, so a simple example of regression analysis, one can choose to estimate weight or what explains weight. So this equation that is presented there, we can call it a weight guessing equation, where we want to guess the weight of an individual given their height. In this case, we only have one independent variable, which means we are assuming that weight is fully explained by height, which is not true, of course, because there are other factors that can affect weight. But in this case, we've only included height. Does that mean that there are no other factors that have an impact on weight that could have been included in this model? Okay, they are there. Example, diet, okay, regular exercises, etc. But in this case, let's deal with what we have. Note that height cannot be a perfect predictor of weight. Hello, I think there was a network problem here. There was a network problem, but we are almost done. We can finish off from where we were. Right. So we were saying, given this regression equation, which is a weight guessing equation, remember you use econometrics or regression analysis to estimate these two parameters. And let's say, for instance, we've obtained 103.40 plus 6.38 height. It means that you are able now to forecast, for example, you are given the height of a person, you can be able to predict the weight of that particular person. Okay? Right. So it's a very simplified version of a simple regression equation. So in this module, focus would be on the interpretation of these coefficients. Using regression analysis to explain housing prices. So we make use of the house price equation, for example, cross-sectional, using cross-sectional data. So we can say, for instance, price is explained by, or is a function of size. When you are saying price is a function of size, we are saying size explains the price of a house. But the price of a house is measured in thousands of dollars of the ith house, and then the size of the house is measured in square feet of that particular house. EI is the value of the stochastic error term of that house. So in this case, you can make use of econometrics to estimate, or regression analysis to estimate the coefficients here. Let's say you have run your regression analysis and you've obtained this estimate where we are saying price hit is equals to 40 plus 0.138 size, where price we are given in 1,000 and then size is square feet. So how do you interpret this slope coefficient? The slope coefficient that we are given here is interpreted as follows. If the size of the house increases by 1 square feet, then the price of a house is going to rise by 0.138 multiplied by 1,000. Why are we multiplying by 1,000? It is because the price of a house is measured in thousands of dollars. Therefore, you say 0.138 multiplied by 1,000, you get $138. So we are saying if the size of a particular house increases by simply 1 square meter, the price of that particular house is going to rise by $138. So when you are interpreting slope coefficients, please take note of the units of measurements that are given to measure your dependent variable and your independent variable. It is quite important. Otherwise, you might get a wrong interpretation. That being said, normally in econometrics, you need to know when to interpret the constant term, because normally you are not required to interpret the constant term unless you are taught to do so, because there are cases in which the interpretation of the constant term does not make economic and statistical sense. For instance, the value of the constant term is the value of the dependent variable when all all the independent variables are equal to 0. For instance, if you put a house that has got 0 square meters, can we have a house that has got 0 square meters? No. It means that there is no house in the first place. So it means that the price of a house that has got 0 square meters would be equal to 40,000, because the price of that particular house is measured in thousands of dollars. So we are saying in this case, it doesn't make sense to interpret the constant term. However, there are cases in which the constant term can be interpreted. But at the moment, what you can master and what you can know is the following statement. We are not required to interpret the constant term unless you are told to do so. For instance, in this case, they just told us that what is the exact meaning of the slope coefficient of this. So in this case, we are just interpreting the slope coefficient. And this one, the constant term, doesn't make sense theoretically, economically, and statistically, because you can't say a house with 0 square meters would cost $40,000. It doesn't make sense. Okay, so we are going to look at this deeper. Remember, today's class was just an orientation to this module and what we can expect in future, because what we have noted as an institution is that a lot of learners will start to do the module behind time when they could have started it earlier on, so that you are able to complete the entire module, and then you can see the areas that you need to revisit more. Some of these learning units in this module, they are very simple, okay? Very simple. Others, they need more attention and more dedication for you to master them, right? And another thing, given that this exam is going to be written as an open book, normally if something is an open book, obviously the level of difficulty would not be the same if that exam was written as a venue based. So my advice is that at this level, it's not only about understanding the theoretical part, but it is also about the application, because they are going to, normally from the past 2 papers that have been written in this module, if you look at the structure and everything, it was a bit different from all the other papers that were written before the issue of COVID-19, right? So what's the story here? The bottom line is that start now to read on this module. And what we can promise as an institution is that we can be able to finish this entire module in about approximately 10 classes, because to my experience as the facilitator for this module privately is that we can be able to cover 1 learning unit per every session, which means that to complete the entire module, we might need a minimum of 10 classes, just like the one that we've done today. And after that, you can now be able to answer any exam question, right? If you don't understand, you can answer, and then we can discuss in the group, and we can move forward. And then those who are also doing other modules, like for instance, monetary, international trade, international economics, there is public economics as well. There will be also some sessions just like this one, so that people don't just cram, pass and go, but they understand deeply what the module content is all about. So as an institute, we advise you to, like what I've said before, start now and prepare for your exams, even when it's a bit far, but the early bird catches the worm. So just as a roundup, because this was our last slide, just to round up, you might be interested in us doing these classes as well. I understand maybe the time might not be conducive with you, but you are interested. You can just inbox, and we can give you more details on how we can facilitate this module and make sure that we can complete it on time, right? So it will be good if you can have 2 sessions per week, so that you can even complete it in lesser weeks, because the more meetings that we have per week, the earlier we can be able to complete the module. So right now, I can leave this opportunity for those of you guys who might want to ask general questions, specific questions that might need to be addressed now, so that we can be on the same page.